And we're back with Part 1B. We're looking at the review for mastery for section 11.1. Here we go. So there's some notes here. You can take a look at them, but let's just jump right in. The first one, what's it asking us? Identify each line or segment that intersects a circle. Okay, so first let's talk about these lines. We got line L, crosses twice through it, and it's a line. So line L is a secant. So line L is a secant. Excellent. M here only touches once right on there in the edge. So line M is tangent. Cool. And FG would be a chord. And we could even say HG and HF are both radii, or a radius. Okay, so that was pretty easy there. Let's see what else we got going on. Looks like line MN is on the outside there. It's just touching at this one place, so that's tangent. Then we got line LM, which goes all the way through, so we're going to call that a secant. And then KJ here is going from the center to the edge. That's what we would call a radius. Okay, still doing some pretty easy stuff here. Find the length of each radius, identify the point of tangency, write the equation for the tangent line at that point. Okay, so I'm going to just kind of focus on the important stuff here, mostly the length of each radius, because we are going to be using that later. And we'll identify the point of tangency just so we know what that's really talking about. So first, look at number 3 here. And N, circle N, has a radius. It starts at 1 and goes all the way down to -2. That's a distance of 3. 1, 2, 3. And for P, that has a radius of 1. And the point of tangency is right here where they both meet. That'd be at, we'll call it the pot point of tangency. That's at -1, -2. That's where they meet. Okay, same thing for the next one. We got a radius of 2 and then a radius of 4. So circle T has a radius of 2. Circle S has a radius of 4. And the point of tangency, the POT, is right here. Well, what point is that? We got 2, 4, 6, 7, 0. 7, 0 would be the coordinates. All right, so that's that. Let's look at some more complex calculation here. Really not that big a deal, but you have congruency when you got tangents that intersect at the same point. So let's do that. That means that this piece and this piece are equal. So 2x equals x plus 3. Subtract x. You got x equals 3. No problem, right? That's it. Oh, but wait, it says find BC. So we know x equals 3, so this is 3 plus 3, which is 6. So that's the answer for that one. LM, we got y plus 6 and 2y minus 2. Again, very easy algebra here. We just set them equal to each other because they're both tangent and they both connect at the same point. Add 2 to both sides, subtract y from both sides. We'll have y equals 8. Okay, so y equals 8, and it's asking for LM, which would be this one, but it doesn't matter which one I plug in because they're both the same, so I'm going to plug it into this one because that one looks easier. 8 plus 6 is 14, so it's 14. There we go. Alright, we got the same pattern kind of going on. This time it's 5y and 3y plus 4, so 5y equals 3y plus 4. Subtract 3y from each side, and then 2y equals 4. Divide by 2, y equals 2. Now we've got to plug that in, so this would be 5 times 2 is 10. So it's 10 and 10, it's all 10. Alright, last one. It says 2x plus 5 is going to equal 3x minus 2. This is way easy algebra. I think these equations are too easy for you guys. We need to step it up a little bit. 7 equals x. No big deal there, but when you plug it in, let's see what we get. 3 times 7 minus 2 equals 21 minus 2, or 19. Down here, same kind of idea. 2 times 7 plus 5 is 14 plus 5, or 19. Oh, it's 19 because they're the same. Too easy, right? Way too easy. Pretty sure this is the end of part 1. Let's double check here, though. Let's see if we got our... Yep, there it is. So, happy face. We will see you soon in part 2.